Alright, in this video we're going to practice how to convert between the concentration of hydronium ions, hydroxide ions, pH, and pOH. First thing I have is I have a solution of 0.00375 molar nitric acid. Well, first thing I can do is know that that's going to completely dissociate, so that's going to leave me with 0.00375 molar hydronium ions, or in this case, hydrogen protons. So that's 3.75 times 10 to the negative third. We're talking about the same number here. Now, what I need to know is I have my coefficient of water. The concentration of hydronium times hydroxide is going to be 1 times 10 to the negative 14th. Now I'm going to plug in here. I have my concentration of hydronium, 1 times 10 to the negative 14th, divided by my hydronium concentration, 3.75 times 10 to the negative third. That's going to work out to be a concentration of hydroxide of 2.67 times 10 to the negative 12th. So I'm going to put that in for my hydroxide concentration. Now for pH, that's going to be the negative log of the concentration of the hydrogen ion. So that's 3.75 times 10 to the negative third. Put that in, that's going to give me 2.43. The fact that it's below 7 means that we're looking at an acid. For pOH, I'm going to do the log of the hydroxide ions, 2.67 times 10 to the negative 12, which I pulled from here. That's going to give me a pH of 11.57. Now, another way I could find the pOH is going to be 14 minus the pH, because remember, they're always going to add together to make 14. So 14.0 minus 2.43 is going to give me 11.57. I get the same result either way. Next up, 2.46 times 10 to the negative 9th molar potassium hydroxide. That's going to completely dissociate, so I'm going to get 2.46 times 10 to the negative 9th molar hydroxide. Now remember, hydronium times hydroxide is always going to be 1 times 10 to the negative 14th. So solving for this, I'm going to plug in my concentration of hydroxide of 2.46 times 10 to the negative 9th. That's going to give me a concentration of hydronium of 4.07 times 10 to the negative 6th. For pH, the negative log of the concentration right there is going to give me a 5.39, which means this one is also going to be an acid because it's below 7. For pOH, that's going to be the negative log of the hydroxide concentration. That's going to give me 8.61. And again, the other way to do that is 14.0 minus the pH is going to give me the pOH of 8.61. I get the same thing either way. 1.12 times 10 to the negative 5th molar calcium hydroxide. Now you need to recognize here that this is going to dissociate to form twice the amount, so it's going to give me 2 moles of hydroxide for each 1 mole I'm going to have of calcium hydroxide. So I need to take my concentration and multiply that by 2. So that's going to work out to be 2.24 instead of 1.12 times 10 to the negative 5th. Working this out using my coefficient right here of 1 times 10 to the negative 14th and solving for the hydrogen proton right there. That's all going to solve out, dividing by my hydroxide of 4.44 times 10 to the negative 10th is going to be my concentration. pH, negative log of that number, 4.44 times 10 to the negative 10th, is going to give me 9.35. That's going to be a base because it's above 7. pOH is going to be the negative log of this number right here. That's going to work out to be 4.65. Again, the other way I could get this is 14 minus the pH is going to give me the pOH of 4.65. Same thing either way. All right, a solution with a pH of 4.37. So that one I can already pull from right there, because that one's going to be an acid below 7. pOH, remember that's 14 minus the pH of 4.37, that's going to give me a pOH of 9.63. Now, to solve for this, to get backward from pH to the concentration of the hydronium, that's going to be 10 to the negative pH. So 10 to the negative 4.37, that's going to work out to be 4.27 times 10 to the negative 5th. The concentration of hydroxide is going to be 10 to the negative pOH, that's going to work out to be 2.34 times 10 to the negative 10th. Remember, negative pH is what you got to do up there, following that. All right, pH of 12.0, that means it's going to be a base because it's above 7. pOH is going to be 14 minus that, so 14 minus 12 is going to give me a pOH of 2.0. The hydronium concentration, 10 to the negative 12th, that's going to be 1 times 10 to the negative 12th molar, and the concentration of hydroxide is going to be 10 to the negative 2nd, or 1 times 10 to the negative 2 molar hydroxide concentration.